to 10.4. Our math learning objective, I can fill out the unit circle to identify trigonometric ratios of special angles. So what is the unit circle? It is the circle with equation x squared plus y squared equals 1. And if you have x squared plus y squared equals 1, then it has center 0, 0, right? Because nothing's being subtracted from x and nothing is being subtracted from y. And keep happening. Hold on. And radius 1. The values of sine theta and cosine theta are y and x, respectively. We'll kind of see why that is really quick. Respectively. Okay, so yeah, the unit circle is the circle with equation x squared plus y squared equals 1. Right, so the radius is 1 unit. This is why we call it the unit circle. And it's centered at 0, 0. Right? And this unit circle helps us to find sine and cosine of any angle we draw on, right, as we go around the quadrants, right? So, for example, it has this random point here. We don't know what the numbers are, but we call it x, right? The x value is x, and the y coordinate is y. Okay, and like we did yesterday, we can draw this lovely line. So then I went over x, and x is negative, but we're not going to put negative x, right, because x is just here. And I went down y, right? This is the x coordinate, this is the y coordinate. Then if I'm finding sine of this angle here, then I'm doing, for sine, I'm doing opposite over hypotenuse, which is y over 1. Y divided by y, 1 is just y. For cosine, right, adjacent over hypotenuse. Well, looking here, my adjacent side is x over 1, which is just x. So if I know a point on this circle, any point whatsoever, just given that point, I then know the sine and the cosine of the angle that passes through that point, right? Because it's just the x, the y and the x. Okay? We're going to use that information to fill out our lovely circle. Oops. Down here, which we are going to do in class. So we're going to skip this part for now. We're going to fill all of this in class and kind of talk about how we fill everything in and where everything comes from. So go ahead, turn the page. And we're going to look at our reference angles. Sorry. Well, what is a reference angle? So a reference angle, so let theta be an angle in standard position. the reference angle for theta is the acute angle theta prime formed by the terminal side and the x-axis. So it's the angle, the acute angle, theta, this is a little fish, tick mark, theta prime, formed by the terminal side and the x-axis. Okay. So in quadrant 1, the angle that if your angle falls in quadrant 1, like that is your reference angle, right? If you draw 30 degrees, it's a 30-degree angle. We know those special trig values. Okay? So it's once we get into these other quadrants that we don't know the special trig values for, but we can use our reference angle to find them. So for example, if I'm in quadrant 2, right, here's my theta, right? So I always want to go to the x-axis. So it's over here, so to the x-axis is this. I'm going to look at this angle. And you think it's just 180 minus, if I take away this, right? How far away am I from 180 degrees is basically what it's asking. If I'm in quadrant 3, same thing. I'm past 180 degrees, but still asking how far away are you from 180 degrees or from pi. Reference angles are always positive too. Quadrant 4, right? If I'm over here, now if I'm going to the x-axis, it's how far away am I from 360 degrees or how far away am I from 2 pi. Okay, so if it's in one of these quadrants, how far away are you from 180 degrees? If it's in one of these quadrants, how far away are you from 360? Okay, so let's look at some examples of that. Find the reference angle for 5 pi over 3. So we want to start by graphing. Again, for radians, we need to split my top half into our 3 equal sections. Same thing with our bottom half. Then when I draw my angle, I'm going to go 5 of them. I have 1, 2, 3, 4, 5. So then, you're always asking, is it closer to 180 slash pi or 360 slash 2 pi? So for this one, it's closer to 360 slash 2 pi, specifically 2 pi, right? So I'm finding this little chunk here. For radians, I almost think reference angles for radians are easier than degrees. They're harder to draw, but once you draw them, then it's really easy. How far away am I from this? Well, I'm cut into thirds, and I'm 1 section away from that. So it's 1 pi over 3. We'll call this theta. All right, looking at B. We have 130 degrees. Sorry about all the bells. Right, so it's going to be between 90 and 180. And then it's closer to 180 or pi than over here, which is 360 or 2 pi. So we're finding this. So I want to know how far apart are 180 and 130 degrees. Well, all I'm going to do is 180 minus 130. Always do bigger minus smaller. So my reference angle there is 50 degrees. Isn't a great reference angle? So you don't know that angle, but that's okay. The reference angle is still 50 degrees. All right, for C, 240 degrees. We're going to, again, go 0, 90, 80, 270. All right, and it should fall in between here, right? 240 is between those two. So we can draw our angle like this. And then which one is it closer to? Is it closer to this or this? It's closer to 180 degrees. So that's going to be our prime. For these ones, it's always going to be bigger minus smaller. So 240 minus 180, which is 60 degrees. What that is. So that's our reference angle. Our last one, 17 pi over 6. I have to cut it into this into 6 pieces, so I'll cut it in half first. Cut these guys into thirds. Same thing on the bottom. Cut these guys into thirds. Lots of lines. And then we want to do 17 pi over 6. So I draw my line here, and I'm going to go 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, but we made it all the way around. So this one went more than once around. But it doesn't matter. My reference angle is still just this piece here. And again, for, let's leave it over there. For radians, I like to just look at the fractions. This is a 6 of that. Right, I cut it into 6 pieces. I'm only doing going one of them. Alright, so for radians, there's not really any adding or subtracting. It should all be in your picture. And that's it. I'll see you guys tomorrow.